All right, it is 11:03, so let's get rolling. Yeah, good morning, good afternoon, and good evening even to some of you. It is 11:03 a.m. here on the West Coast of America. I am your host today, Larry LaMotte, and this webinar is being recorded and will be made available online at YouTube later. So getting into it, a bit about us. ReCapturit, we're passionate stewards of salvage. We're extending the life of building materials and buildings, working on a comprehensive, holistic plan for amplification of reuse and deconstruction in three facets: a solution for construction waste, the marketplace and the place to shop for and sell treasures of recaptured building materials at ReCapturit.com, and why we're here today: help for cities to craft clear and effective reuse and deconstruction initiatives and policies, which is sort of the broad scope of today's discussion as part of what we call the Deconstruction Policy Accelerator, or the DPA, which rhymes with EPA, which is not a bad thing. What is the largest waste-producing set of practices in the world? I think we all know: construction and demolition. And what is the single best solution for eliminating that? Deconstruction. Deconstruction and reuse of building materials and capturing them rather than demolishing and disposing of them. And we as a company have entered into the world of planning and policy to help with that, so cities and counties across the US and Canada can move more into that realm. Each of these events, each of our webinars and our workshops builds onto the previous one, and this is our 7th now. And a couple of workshops are in the can, as the theater people say. It is an ongoing series. It's provided to educate, to inform, and even inspire you and us and all of us, government officials, all of you sustainability champions, to understand the need to move toward deconstruction from the total demolition and disposal of buildings. Because these are not soggy paper picnic plates, people. I had to practice that one. Soggy paper picnic plate. Yeah, give it up. Yeah, they're not soggy paper picnic plates, people. We're throwing away whole buildings. And there is an urgency to move things forward. And there's a lot of activity in that realm, which I'm excited about. But we've seen a lot of same old sort of sluggishness. And yet there are a few bright spots of courageous initiative. Portland, Oregon, and San Antonio, Texas, Boulder, Colorado, Minneapolis, Minnesota, Milwaukee, Wisconsin, upstate New York, Savannah, Georgia. But we need more. That's just a few little pinpoints on the map. We need to accelerate things. So that's why we're here. We have talked in our webinars about the basics, about tax benefits, about city officials who have made things happen. We've talked about the reduction of carbon dioxide and methane into the atmosphere. We've talked about tools and even how to think about such complex problems. Well, today's webinar will be a series of questions tapping into the knowledge and the expertise and the envisioning capabilities of two extremely smart and innovative experts, PhD Vicki Meckler and PhD candidate Aida Mollaei. And we will be talking about new thinking around supply chains of recaptured building materials and new technology that cranks up the capabilities of accessing previously unrealized value of buildings and building materials in your cities. Yep, this month's topic: reimagined reuse technology transforms supply chains for used building materials. That's me, the goofy guy there in the glasses. I'm your host, founder and CEO of ReCapturit, creator of the DPA, the Deconstruction Policy Accelerator. My background was in architecture. I went into construction and remodeling and design build. I built our own house. I was in facilities management for about 11 years, taking care of other people's buildings. ReCapturit is my 7th business, started from scratch, and I am a lifetime scrounger of materials and a fighter against waste. But this ain't about me. This is about our terrific panelists. We have two incredible experts with us today, Vicki Meckler and Aida Mollaei, and they're going to share their ideas with you, and at the end, answer some questions. You can put your questions in the chat here. Look for the little chat bubble wherever it is up there. I'm going to drop our contact information into the chat, so maybe that will even highlight where it is for you while we're doing that. Right there. That is Vicki's, Aida's, my and ReCapturit's information. And here we go. All righty. Vicki Meckler, let me tell you about her. She is the Senior Integrated Supply Chain Optimization Consultant at Arkiva in Philadelphia, Pennsylvania. Ms. Meckler has degrees in mathematics and operations management with her PhD in operations research and management science. She knows how things move in systems. Aida Mollaei is the co-founder of Adaptus AI, and this is a fascinating technology company to me. It's focused on enhancing the circularity of buildings and building materials. And Ms. Mollaei has degrees in civil engineering, a master's in sustainability management, and is working toward her PhD in civil engineering. So these are very smart, very informed, very experienced experts in these fields. And I'm just thrilled you're here today. So oh, there's their picture. Sorry, I didn't get that up quicker. Let's get talking with them.
Larry, we're only seeing you, which is certainly pleasant enough, but if you're
you're very
some
kind.
Slides.
Wow.
Just FYI.
No, I appreciate that. Thank you. There, so let's go back. There's our panelists today, Vicki Meckler and Aida Mollaei. And I'm sure I got a little blush in my cheeks for my goof up there, right? That's okay. I'm used to it. So buildings deteriorate. Buildings outlive their usefulness. Buildings die. How do we move from the current ineffective model of sending the majority of mostly demolished yet still usable building materials from their path to their demise in the dump? And how do we create a new model of reuse, optimized for architects and builders to specify, access, and purchase materials for larger scale new construction? We move building materials from this and this to this, the reuse of materials. Yay. But how? Through this. New thinking, new models, and new ways of doing the business of moving these materials. So now I am going to shut off the screen sharing, which I should have done initially, but hey. All righty. Now, let's talk. Vicki, let me ask you first. Would you please tell our audience about the work that you do and how that expertise can assist us in understanding such an established supply chain system as there is now currently in building materials products, the new building materials products, and why there would be such resistance to change to incorporate used building materials? You have 5 minutes.
Well, hello, everybody. Thanks for the introduction, Larry. As Larry indicated, I'm a bit of a math geek, mainly applied math, and I tend to apply my math to supply chains. Also done a little work in the energy industry, but mostly on supply chains. So what I do mostly is build something called optimization models, which is essentially a methodology for balancing competing resources and other rules and things that need to all be respected in order to get some sort of plan of action. So in most of what I do, it's in the supply chain realm. So in terms of what are the challenges around, why is there a resistance to change? Well, mainly because people don't like change, right? They look for a quick fix. And when you do a quick fix, you're cutting corners, it's square peg, round hole, and you tend to slow yourself down more than you advance the needle. Specifically within supply chain management happens at 3 levels: design, planning, and execution. And many make the mistake of doing all 3 at once. And I think that's part of the challenge. It's very important to separate, starting first with the supply chain design. And in the case of deconstruction, we can't think of it as an add-on. We can't think of the reuse of materials as an extension of a traditionally linear supply chain. We really have to change our mindset and think of it in terms of a circular supply chain. Circular supply chain is not just about reverse logistics. It's not just about getting the materials where they need to be. It also feeds into the way we produce our items, the way we design our buildings, with the notion that they will be deconstructed later. It's a change in the way we think about procurement. We don't just run to Home Depot. We go to places like ReCapturit and other of these clearinghouse type places. And then you have the whole design. So the design of the building, the production of the components, the procurement of the components, all of that needs to change to fit a circular supply chain. So it's a lot of work. That's why there's a resistance, right? Reuse procurement feels cumbersome right now because it is much easier just to go to Home Depot and just order everything you want in one place. You know, you feel safe that you've got the consistency and the uniformity of your materials. You feel good that you're getting good prices and so on. And so the reason that the reuse mindset feels cumbersome is that it doesn't fit the current paradigm. And that's what we're trying to do, is fit it into the current paradigm. Which is why it's so important that we have these early adopters like ReCapturit, like Adapsys, because what they're doing that's so important is that they're closing the gap. They're supporting the new design of the supply chain as opposed to trying to force fit something into the current supply chain, and that's the resistance that we're seeing now. It's a little bit like EVs and charging stations. Nobody wants to buy an EV because there aren't any charging stations, and nobody wants to buy nobody wants to build a charging station because they're afraid there aren't enough EVs to use it, right? And so we go through that balance, that dance for a while, and then eventually we'll hit the tipping point. So I think that's the situation that we're in now, is that we just really haven't moved into the new design. And once we do that, with the help of these early adopters, then we're going to see an acceleration and more buy-in, and then we can start getting into the planning and execution of the supply chains. And at that point, it's going to be much easier, right? There'll be some changes to the way we do business. There'll be some changes to our metrics, our performance metrics. But once the design is in place, the rest of it will follow much more smoothly.
Wow. Nice. Thank you. That's everything I wanted and more to hear. So I appreciate that. That's fantastic. And speaking of the not fitting it into the current paradigm, that is exactly it. We're trying to make a system not to do what it doesn't want to do. So yeah, you said that very, very well there, Vicki. Thank you. Aida, would you please describe what your new company, Adaptys, does at adaptys.ai? A little plug there. What it does and how one type of the several technologies that you're developing can assist in the amplification of reuse of building materials into new construction and other creative uses. And by that, I mean, how can the technology be used to access the quality, quantity, condition of used materials in existing buildings and more? And I don't want to be the spoiler of the news that you bring. So tell us, please, what all can this do?
Yeah, for sure. First of all, hi, everyone. Thank you for having me on this webinar. It's a great opportunity for me to present our company and our team. So Adaptys is a decision support platform for building decarbonization planning during the whole life cycle of a building, which means from phase A to phase D, if folks are familiar with the life cycle language. It's a little bit of context there. As we all know, in a life cycle of a product or a process, we have the material extraction from virgin materials, then we have the processing to build the product, and then we have the use stage and the end of life stage. In a building context, it's kind of the similar logic. We have the materials, we do the construction, the transportation, then the use stage involves both the maintenance, so use of the materials, and the use of the building. This is something that in the embodied carbon language is missed occasionally. So when they say use stage carbon, they only think about energy consumption and water consumption, but we also want to make sure materials are healthy during that kind of stage by improving the efficiency of those materials. And then we have the end of life cycle, which is this phase C, where it's for the demolition and deconstruction of the buildings. And then phase D, which is the beyond life cycle part, where we can have positive impact, meaning we can do the reuse, recycling, all the cool things that we're all here to talk about. We have different products and services catered to these different life cycle stages. So if a building owner comes to us with an existing building that wants to improve energy efficiency, we work on that. But what I'm here to talk about is our end-of-life focused product, which is our salvage assessment services. What we do is that we intake simple building information from building owners. They normally don't have any fancy Revit model, mostly plans, pictures, even they give us an address. We go on Google Maps, take a picture, and we try to predict what this building contains. The more information we get, the better prediction we have. But because we do have this large database in-house, based on the location, based on the age of the building, kind of the general structure, we can predict the basically all the materials that are embedded in that building. Then with this information, we have an inventory or like a takeoff of that building, and we look at different costing information, salvage values, and possible reuse options for those buildings, again, based on available data sources from locations around that building or from previously collected databases that we have. Using all this information, we predict the optimal end-of-life solution for each and every single element of that building. So in this way, before actually going into the deconstruction process and bringing the building down, we know what's in it and where it can go. It's like having an inventory without the need of the warehouse or their storage, which is kind of one of the issues that we have in the whole reuse logistics process. As more data comes into our platform, as more assessments are done, we will have a larger inventory of these different buildings located in different locations that are coming down at different points of time. This way, if we need to capture information about, what is the kind of available market for those materials, what are the availabilities, we can get those materials easily and design for reuse. And that kind of circulates back into what Vicki was saying about designing for disassembly and designing for that from the early stage. Well, we know what is coming. We know what to design for before the building coming down. Technology is very capable, and I think the AEC industry is a bit lazy at kind of adapting to these new things. What again we try to do is find those pain points with small products, with small services, and then introduce those technologies there. Not using any buzzwords, just saying, okay, you want to do a salvage assessment, give us your building, we can assess it for you. We can give you the inventory, similar like a normal takeoff, or someone would come, do a deconstruction assessment for you. We believe that this is an easier approach than going with super complicated technology.
Okay. Wow. All righty. So I'm going to highlight a couple of things that you said in the midst of what you just shared all that with us. Costing. I don't want that to slip by our audience, but what you are actually doing is you are determining the qualities, the quantities of the materials within the existing building as it stands and costing it, giving it a value in current market terms of its I'm guessing the scrap value, reuse value, recycling, and then even the disposal of the minimalized waste. Is that correct there, Aida?
Yeah, so we look at what is the potential for the materials that are in higher quality, the reuse value, and then things that need to be recycled. What is, if there is a value gain there for recycling the scrap, or if you need to pay a fee for those to be recycled, and then those materials that actually need to go to landfill, what is the cost for landfilling? And all of this is like part of a building system. And that's why we need an optimization. So we say this one needs to be reused, this one needs to be recycled, this one is not in good quality, it's a cost liability for you, you need to dump it. Kind of this is the solution here.
That's what lit me up when you and I first met and first talked about this, is that that possibility that you give that quantified dollar value of things. And that is valuable information to building owners, particularly those who have derelict buildings that are just sitting idly as a balance sheet negative. So yeah, wow. And we might get more into that inventory aspect you hinted on there too, but let's keep moving for the moment. Vicki, off to you again. Would you please speak to disruptions in supply chains, such as we have seen many of in the last few years, the Suez Canal accident, trucking labor, the freeze in Texas that shut down resin production for wood products, and how such disruptions occurring within the new material supply chains would not be the same as those in the used materials supply chains. And so would you please speak to that?
Sure, happy to. So when we talk about sustainable supply chains,
You're a little you're coming in very gravelly at the moment. Perhaps your speaker did something. Your microphone. You were clear as a bell a moment ago, and now you're not. Try it again.
no?
No, not yet. Not yet. What? Perhaps you could. Would you sign out and sign in again, perhaps, or something? Because we won't be able to understand you otherwise. And I'll move to Aida for the next, and we'll come back. Okay. All righty. So Aida, let's move on to the next one there. Picking up on what you said just a minute ago, how can digitizing inventories of used materials be beneficial to the burgeoning reuse industry, as in matching used materials with existing categorization systems of new materials using BIM and master format and Revit software? And what advantages and efficiencies can this bring for adoption of used materials into the into the intransigent new building products supply system?
Yeah, so digitizing these salvageable materials, this inventory, is definitely a game changer. So imagine any type of inventory that we have, even like for a normal shopping. It's going to refer to like kind of, let's say you're a builder, you're looking for 2x4s, because we mentioned 2x4s today. You're looking for virgin materials. You go on an online shop, say you go on Home Depot or something, and then you look for the material, you find the match, you order it. This is exactly like similar thing that we do with any other shopping thing. The same applies to salvaged materials, but this time it's not a certain shop. And then the categories of the attributes of those materials are also limited in different shops. Let's say you want a size for a clothes that it's not available everywhere. So you have to look for the best place to buy it. So going digital on this inventory, the salvageable materials, is like easily finding those materials and the right source for you to get them with the correct kind of attributes and characteristics that you want. At the same time, this is for like the person who wants to buy it from the demand side. On the supply side, you can also continuously update what you have to offer, your salvageable materials. Let's say as part of a deconstruction process, or even before going into that, the actual implementation, you have different studies done, you have different assessments, you have updated images, there is new kind of assessments done on the value of those materials. You can continuously update them, so people who are looking for that material are more aware and are kind of updated on the new conditions of those materials. The ideal next step is that when we can have an optimal match based on the location and the need for the different materials. So let's say we have a group of users looking for a certain reusable materials they want to use with described attributes and sizes and different densities and stuff like that. And then we have a group of people who are deconstructing a building and bringing it down soon that contains that material. Ideally, we would want to match these people, so they would know what is the best and closest source for them to get that building, to get that material. This will save costs and hopefully like environmental benefits on the kind of the logistics side and the reuse side for both sides. So from the suppliers side, they have more confidence in the revenue they can generate from these salvageable materials. So they'll have more confidence in the extra cost that they have to bear with the deconstruction. They know that they're going to make that through the revenue generated from the salvageable materials. And also the person who wants to buy that knows that they can actually get that material with that specific attributes. The question that I often get asked is, how do we ensure the quality? It's obviously not that simple. There is no way to say with 100% before actually looking at the material that this component has that specific attributes. But again, as I mentioned, data can help. The same logic that a person would follow when they want to assess the quality of the material, we can automate that. You look at the images, you see something's wrong with it, you do some tests. All of those can be done through image processing and through looking at previous data. Not 100%, I'm not confident, like it's not something that you would say, oh, for certain, I know this component is reusable. But as we collect more data, the predictions get more accurate, and these inventories will have, people will have more confidence in these kind of digital inventories of existing buildings.
Exactly. Good. Yes. We had to deal with that too in ReCapturit, the quality materials, and people were used to putting one picture up on Craigslist, and then because the transaction didn't happen there, it happened in person. But when it happens online, what you're speaking to, Aida, that's when you have to have the quality of the photos, the quality of the descriptions, and you might have to do what they did in code revisions for lumber, which is to sort of downgrade the lumber, even though it doesn't necessarily any worse, it's probably better, but just to be safe. So anyway, this is fascinating stuff. Anyway, Vicki, welcome back. I hope
You hear me?
Oh, yes. Oh, you're back in crisp clarity. Good. So please, so please speak to the disruptions in supply chains, like the Suez Canal or whatever, versus new versus used, if you would, please.
Sure. So what I was saying is, on the topic of sustainable supply chains, we talk a lot about shortening the supply chain. Traditionally, linear supply chains, these sort of global supply chains where products sometimes literally traverse the globe while getting produced. The longer the supply chain, the more opportunities there are for disruptions, loss, additional costs, right? And all of these, because of the super long lead times, that translates to more inventory, which comes with a whole set of additional costs and challenges and so on. So what the reuse paradigm brings us is the ability to shorten the supply chain. Because we are not starting with cutting down a tree anymore, we're starting with simply pulling the lumber out of an existing building. Just that part right there takes a huge chunk of the traditional supply chain out of the equation. Exactly. And the benefits of shortening the supply chain, you're replacing production with rework, which potentially, not always, Larry, you had that great video of them pulling the nails out of the wood, which was really cool. So there is rework, there's work to be done, but it's most likely going to be fewer steps and fewer processing, which means better yields, and just a shorter amount of time. As what Aida was talking about, where we're matching now customers with sources, potentially that gives the opportunity of reducing the distance traveled, which means less lead time, and less emissions and costs and other negative impacts on the environment. All of these things, when you shorten a supply chain, translate into less inventory needed. A lot of times the reason we have inventory is that we have a lot of uncertainty. We have uncertainty when we put something on the truck. We don't know if it's going to hit a snowstorm. We don't know if the boat's going to get stuck in the canal, right? All of these things cause uncertainty, which we respond to by building up inventory. With the reuse model, while there is a potential to have a lot of inventory at this point, the inventory is pretty lean. And so having these shorter supply chains, it's imperative that we don't need to have all this extra cushion in there to protect against all of these uncertainties, right? So bottom line, this means a shorter supply chain, not starting from scratch every time. Not only are we reducing, I think the reducing the landfill deposits are sort of the obvious, but even beyond that, the benefits include more resilience, more visibility, more responsiveness into the overall system. So it's as win-win as it can get, I think.
That is a great way to wrap that up. It is as win-win as it can get. Yeah. Thank you. Let's see. Let's move back to Aida and say that I'd like to continue with you on the subject that you hit on and Vicki was just expounding on. and that is, how can digitizing inventories of used materials assist with the planning for optimizing the advantages of reuse, such as the minimizing of travel distance and drastically reducing carbon footprint of new construction, and knowing what that is, and maintaining already sequestered carbon, and even the tracking of life cycles of materials? How does your technology help with that?
Yeah, so having a streamlined automated logistics process for building reuse can improve both efficiency in financial and environmental aspects. And that's kind of the core focus of our tool. So going back to the kind of matching example that I mentioned, when we have all the the needs of the person, the demand side, and then we have the supply, it's just like equations and just an optimization of matching this, finding the right distance and finding the right kind of attributes and the sizing of the different materials that is requested. As I said, this is again win-win for both the supply side and demand side. The demand, they will get what they want in the shortest time possible, and then the least costly way possible. And for the supply side, they're sure that they can actually sell it. And that's kind of this is a bit tricky in the reuse side. So we have deconstruction projects, and like how do we make sure these materials are going to a place they're actually being reused, and how are we sure that we sell it? So that's on that side. We try to kind of reduce that part. Another thing with this whole digitization and then inventory, other than this logistics side, is even the tracking of the material is valuable. There is this popular saying of we cannot manage what we cannot measure, and that's true. So right now, if we are doing deconstruction, we are doing reuse, but we don't actually effectively track what's happening. We have these rough numbers of, yes, demolition industry, construction industry is emitting this much carbon, and then we're saving reuse. But then if you actually have this data and track it effectively, we can find better intervention points, finding, okay, this is a place that we have bigger emissions. Let's focus on that. This part, apparently we've done whatever we can do. Let's not focus on that anymore. There is in the kind of research world that I was involved in, there are still some work about the trade-off of reuse and then the reusing virgin materials. So if you need to do a lot of post-processing when the material comes out, a lot of transportation, sometimes it actually turns out to be more environmentally harmful for certain materials, not all. And if you can actually track that and then find the best way of, okay, if you travel longer distances for this material, it's not worth it to reuse it. So reuse the other ones. And if you find someone that can reuse the specific material closer to you, then reuse that one. So we actually answer this question as well. Again, all of this is possible with data, with the correct data that we get. Another really cool advantage of digitizing that I want to talk about is when we have all of this, so let's say we don't actually use it, it will enable us to do a lot of predictions. This, as you hear about AI and machine learning, it's nothing but data that they have, and they look at the patterns, and then you can predict. All these ChatGPT is based on all the things that we wrote over these years, and then it knows what to say because it has seen a lot of different things that we have written all over the internet. So if we now have all this data of, okay, how did things, how did a deconstruction project go? Who salvaged what? And if we have hundreds of these projects, then we can easily predict that. So even if right now people don't see the value, like, okay, I have my, consultant come and help me. Yes, but if we track that data down the road, we can enable scaled deconstruction, which is, far away from these small projects that we do. We have, policies in different counties doing single family houses, small, maybe multi-unit residential buildings, but to actually build this on a scaled position to have this implemented globally, we cannot, get ourselves limited to, okay, someone coming and addressing the salvage values and putting it in a spreadsheet. These spreadsheets are going to get lost. I know we all have lost spreadsheets on our laptops. And then if we have a correct structured way of tracking this data, it's not going to get lost, and we can make predictions and have a better streamlined process for all the things that we think that are challenging in reuse.
Wow. Yeah. Okay. Thank you. You've hit on you both are hitting on some of the key ingredients of this, the information that we can get that enables the modeling of new systems, and supply chains, and tracking efficiencies and so forth. So Vicki, I wanted you to pick up on that a bit too. And given that the sourcing and the processing, the transporting and storing of used building materials differs from new building materials, can you speak to what some of these technological advancements might help used building materials close the gap with new? And I'm speaking into your world, that of modeling based on having access to information that barcoding, categorization, standardization, blockchain, life cycle tracking, inventory management, et cetera, can afford the work that you do to enlighten you, to inform you, and to do better at modeling new supply chains. Speak to that, please.
So as anybody who's worked with any sort of modeling will tell you, the solution is only good as the input data that you give it, right? So having the most accuracy, the visibility, transparency, robustness of the input data is paramount to having a usable, executable supply chain plan. And that's kind of supply chain 101. So all these things Aida's talking about directly relates to that. And a little sidebar, because as I was listening to Aida and thinking about these questions, it reminded me of, I worked with the FAA for a while, and what I learned about that is that they have a required amount of separation between planes when they land. They have to be 2 miles apart for the distance. And the reason for that, there is like the jet wash, you can't be right up behind a jet plane, but the bigger reason for the distance is that the radar equipment, at least at the time when I was doing it, they never knew exactly where the plane was. And so they had to sort of guess. And so there was like some fudge factor, and they created this buffer zone just in case. And as the technology gets better and our visibility gets better, we can put the planes closer together and increase the throughput. So it's a little bit of analogy there, but in terms of the more accurate our data is and the more certainty we have our data, the tighter our solutions can be, the shorter our supply chains can be, right? So it's all related. Another thought I had as Aida was talking is that this notion of scaling, right? Because that's one of the challenges of the deconstruction and reuse right now, is that if I'm building a big office building, I need more than just a few extra, pieces of wood, right? I need a lot, and they have to be the same. And I can't go and get a little bit of this, a little bit of that, and they're not quite the same, and they're a little bit different. I want to have everything very uniform, right? So as grow this ability to have this information, it's a double benefit. We get more volume, which is going to in turn generate more buy-in, which is in turn going to generate more volume. And then we are going to just sort of go from there. And we just have to get to that tipping point.
Wow. Yep. Great. Thank you. I'm going to keep it moving here kind of quickly now, because we lost a tiny bit of time. So thank you, Vicki. Aida, you and I spoke about what I believe to be the most stubborn obstacle sequence in the reuse of used materials, and that being the providing ample volume. And you're both talking about that today, the ample volume, the variety, the condition, and the convenience of specifying and purchasing used materials by and for the architecture, engineering, and construction industries for larger scale projects. They simply cannot get these now. When we discussed your Adaptas AI technology and its ability to quantify existing buildings for their materials, categorizing, quantifying, even valuing for reuse and everything. Remember, I mentioned BAM, the Buildings as Material Banks, which is a system developed in Europe, and I stole that and nicknamed this BALI, B-A-L-I, for Buildings as Live Inventory, where currently standing buildings can be thought of as active inventory until needed, and made available as an online inventory for the AEC community to use as a resource by virtue of your technology. And you have touched on that today. And can you expand on that a bit more? Do you see a future for that? And what would that look like?
Yeah, so we are definitely on the right track as a whole industry. And then Adaptis, again, we capture existing building information aside from the salvage value and the whole kind of deconstruction aspect of it. We still have the quantity and the quality of the materials captured. So even if the building is not coming down, nothing is happening, this is kind of captured in our database. And then again, as I mentioned, mapping that with other local data, it makes it more accurate and more accurate. There are a lot of policies in Europe on forcing something called material passports. It's exactly kind of where the BAM thing all started. What it means is the source of truth for all the materials in that building, alongside any other data that you would need. Even in Canada, I was working with NRC for a while. They have this kind of initiative to launch this national material passport platform, obviously not in the very close future. It's a bit kind of a process. There is a lot of research around what needs to be captured in this data. Because when we lose kind of the correct time to capture that data, it gets less accurate. So let's say when we decide to build a building, right now we have Revit models, we have different drawings that are, we have kind of the specs of that building. And even if at that point we put the quantity, it's not enough. So this material should be live somewhere where we update it. If any renovation is happening, anything, any material is being changed, as this gets updated at the end of life of a building, or anytime someone needs to do a study on the building, this data is already there. Right now, if you look at the business side, building owners spend millions and millions on studies that are just repeated of the same thing. They have PDF reports. They spend a lot of money on consultants because they'd have to go back, dig in the reports, dig in the data to find, what was in this building. Whereas if someone actually captured it in something like a material passport or a building as material bank format, they could have easily gotten that data. What I'm trying to say, because there's a lot of maybe discussion that I don't want to say a bad point, but a discussion about, okay, who cares? Like, why do we need to capture this data? Looking at the simple business side of it, if you have this inventory, you don't have to go find your reports anymore. You don't have to pay consultants to do the same study for you a million of times. I've actually seen this in our company. They give that back to us. What we want to be, what our vision is, the source of truth for all environmental related and cost related information about that building. So if at any point you need to see, what is the health of your materials? What is the condition of your materials in that building? What is that asset worth? You can come to our platform. The incentive here is that when we have this data, when we show the value for the building owners who don't care about the environmental side, is that not only their building and their land is an asset, now all the materials are assets. So now they would see the financial value of that as they in a live format. So as they, as time passes and things happen to your building, you would see it. Again, taking that a step forward, if they have an understanding of their future value of the materials, they will build their buildings in a certain way that the value does not decrease. So taking all those design for disassembly measures into account from day one. What we again do in like a pilot study that we did for a client of ours was that we had different design options and a new construction building, and we showed them how would the assets change over time with different materials and with different systems. So the extra cost that they pay at this time for maybe the more modular system or more detachable connection systems, it will pay off down the road because their asset is more valuable. This is purely on material, and it's nothing about like the policies or the mandates. I think putting that perspective helps with pushing the industry towards that because we cannot rely on the policies to the end. So what we try to do is bring the financial aspect into the kind of the results that we show to the building owners, so they can actually get motivated by that side and forget about the environmental side, just for your own business. it's going to help you.
Exactly. Yeah. Thank you. Yeah. That financial knowledge that you are transmitting to building owners by doing this is immensely valued, because there's really nothing out there to tell them what their building is worth for the materials value now. And even if there is a wide margin of error because the technology hasn't advanced far enough yet, even at 70% with a 30% margin of error, that's still a lot more to go on than they had before, and it will only get better, won't it? So fires me up. Okay, Vicki, let's circle back to your first question and answer here. And how can the work that you do help create a new supply chain system for used materials that merges with and competes equally and even better with newly manufactured materials? And how might we optimize for efficiencies and cost savings and so forth to take advantage of that in this in a new model?
Yeah, thanks. So we talked a lot about how the overall supply chain paradigm needs to change.
Mm-hmm.
And so I think, once that happens and we can show, and I totally agree with Aida that, at the end of the day, people want to be environmentally conscious, but they also run a business and they have to make financially sound decisions. And so I think, and that's the beauty of all this, is it does become beneficial from however you look at it. And so I think that's really important to stress that. But once we have this new design in place, the next step, as I mentioned before, is the planning and the execution. And what I spend most of my days doing is supply chain planning for typically manufacturing companies, but the ideas are the same. And that is, you get that data in there, and now you use that data, cost, availability, value, and you use all those to balance the overall resources. I have these buildings I want to build. I have materials available in these different places. I have options of how to transport it to where I need it to be. Time is it also dimension, right? And so you can go with Excel to start with, but as you scale, the complexities are going to grow, and you really need a sophisticated tool and something like an optimization model, which does all this balancing, plays the whack-a-mole game. You can minimize one cost, but that's just going to drive up the cost somewhere else. And you really have to look at the overall system in one integrated, comprehensive approach to really be able to leverage the systemic value out of it. And that's where that kind of technology comes into play, which is already there, right? That technology is already there. It's just now we're modeling a better design than we were before.
Exactly. Yeah, with new information, new tools, and new incentives, and those that mix is so important. The financial, the knowledge, the data, all that. It's. I think one of you mentioned that we're coming toward a tipping point in all of this, and I can feel it. And I've been talking about that, and I'm excited about that. And when that tips, things are going to start happening big time. So, yay. I am actually going to share my screen properly this time and not forget. So thanks. It's time for Q&A, and we're right on time. So thank you both for keeping us on pace there. I'm going to check the chat channel here to see if there are questions already. Let's see. Daniel Hartzig said, this sounds like it would be a very helpful program for the reuse industry. Are you pursuing the EPA grant due next week for this exact technology? I guess that would be for Aida.
Yeah, so I responded, we haven't looked into that, also because we're not an American entity. I'm not sure if we qualify, but we did have kind of a similar grant in Canada that we applied for. There is the problem with some of these kind of programs is that because we're a software solution, sometimes they're looking for more like a tangible product, and it's hard for us to get accepted. We did get accepted for the Canadian one, but thanks for sharing it. I'll look into it and see if we can maybe do something about it in the short time that we have.
Okay, well, Happily, we have right here with us today Sean Wood from the US EPA, who has answered that, and I should have skipped down to that, but I didn't. So anyway, thank you. Simone Chupin says, Ida, what type of buildings are you currently capturing, and what types of owners?
Yeah, so the solution is theoretically not constrained to any type of building, but the type that we're seeing is like more multi-unit residential buildings around 2-3 stories. Those are the optimal ones for us because they're not as small as like a house that it's like easily done, and they're also not as big as like a, I don't know, 20-story, 30-story condo that's kind of irreasonable, not reasonable to deconstruct. And again, mostly residential, but we did have some industrial, so some large warehouses. This was a new construction, so just kind of like a future prediction for recovery. And the building owners that we work with right now are more larger building owners, portfolio building owners. The reason we targeted these kind of groups is that they have very similar buildings. So they normally have 5-6 archetypes, and they've built them around different cities. So if we assess in detail 1 or 2 of the main buildings, we can easily scale it, and it has a large impact. We did have some conversations with smaller building owners, but those normally do not have kind of the funds to go for what they would say a fancier solution. I don't think it's like a fancy solution, it's a need, but they don't really look into, you know, salvaging and environmental side. It's more about kind of a fastest way and the typical way.
Gotcha. Thank you. I'll ask this one. Things like steel trusses in older buildings, can what you do quantify those, measure them, determine what their characteristics are such that they would become available for reuse?
Yeah, so as part of getting that inputs, if we can identify them, again, I'm saying if because again, depending on the input that we get, we might not be able to see every detail. But if we can see it in an image, or if we have a model from it, like a Revit model, we can find it, and then we will have the specs for it, and then we will assign kind of the salvage value to it based on kind of what we see and what we identify.
Gotcha. Good. And Sean Wood asks also, do you have any upcoming plans to demonstrate uses of the tool?
That's a very good question. I know Larry is asking for a demo too. We kind of finished our main MVP recently, and we are going to demo, have a MVP released by the end of this quarter. We do have, as I said, different products, and because there is a little bit more demand on typical energy reduction, the decarbonization, that we prioritize that. We also just grew our team in the past 3 months, so we have a large team to manage. We're just kind of managing that, but we do have a demo coming end of this quarter, and hopefully I can show it. We will definitely post it on our LinkedIn, and please reach out to us. We do have smaller like video versions, and we have project demos that we can show if anyone is interested.
Gotcha. Good. Okay. Thank you. Let's see. Mike Gable of Construction Junction in Pittsburgh, Pennsylvania asked, and hello, Mike. How are you assessing the value of the reused materials, and what references are you using?
So what we have done for that, depending on the project that we get, this was what we did initially. We looked at closest salvage yards and salvageable kind of salvage stores, and then the more the data that we got, now we can predict them. So for example, if we got a project in Waterloo, which is where I live, I looked at different kind of stores around there and consulted with them and said, okay, if you have this buildings, how much are the materials worth? And then you would see a trend. After a while, you'll see those different. It's just local shops. I don't really like the general numbers because that's not accurate. The more we actually show, okay, this is what we got from this store, and this is the value that they gave us. So it's more realistic, more about the market. It's more like local shops. There's no one reference that we use. You have more questions?
I'm keeping an eye on here. We're getting the questions now. So yeah. are you from Daniel Hartzig, are you making public any of the data sets you have already gathered or generated? For example, your findings and assumptions for buildings of X type, Y size, Z use, etc.
We are not making the kind of the core data public, but we are we do have some estimations on exactly what you said, like, okay, this type of building will probably have this much material, salvageable materials, and this much financial value. It's also in the research papers that I did, they are also public. Again, because it's a bit of a kind of a young company that we are, and we are just putting these things together, we would like to make those kind of final numbers public. But the backend data is something that we do keep within our kind of core engine work that we do.
Sure. Yeah. Okay. Thank you. It is time to wrap it up. So I'm going to cut them off there. And I thank you immensely, Aida and Vicki. This has been great. I am excited about the potentials that you both are describing for the future. Your contact informations are here for anybody that wants to take that down. Like I said, the recording of this will be available on YouTube. I'll send a message out to all of the attendees and registrants for this so that you'll have that. That usually takes a few days or so. Again, our purpose for this is to educate, inform, inspire people about the possibilities of accelerating reuse, and to contact us for our work with the Deconstruction Policy Accelerator. And we cannot cover it all in one webinar, but we've covered a ton today, and we will keep hosting this series to engage with us, ReCapturit, and others like these amazing experts we've had with us here today. And I want to thank Aida Mollaei and Vicki Meckler for such a spectacular job today, for informing us, exciting us about the future, and what that holds now because of what you're doing. So thank you to you two, and thank you to our audience. I appreciate all of you being here, your familiar faces and the new people, and it's right on time. So thank you, and hope to see you all next time.
Thanks, Larry.
Thank you, Larry.
You're welcome.
Thanks, Larry. Thank you
You're
both.
welcome. My pleasure. Thanks, everybody. Great seeing you all here.